Hello viewers on YouTube. In this video tutorial, we want to explain the basic idea behind angle of deviation. So to understand it properly, let's consider the diagram we have right on the board. The deviation of light ray at a plane mirror surface can be explained by the diagram below. So if this point center, if it is represented with O, so line AO can be seen as the incident ray of light. Okay, as you can see, it's being directed towards the plane mirror. So the line XY can be considered as the plane mirror. Okay, perfect. So that is basically the plane mirror. Now, usually when the ray AO, when it is incident on the plane mirror, if it's not being reflected, then it will have gone through the path of these slash lines, the one in white color. It would have gone through this path. Am I communicating? But due to reflection, it instead changes its direction and move this way. And that's why you are able to observe the image. Am I communicating? Perfect. So basically now, angle of deviation is the angle between the path that the incident ray would have taken if not being reflected. Am I communicating? It's the angle between the path that the incident ray would have taken and the path that the incident ray took when it's being reflected. I hope I'm able to compile that in the very best possible. Is the angle between the path that the incident ray would have taken if it is not being reflected and the path that the incident ray took when it's being reflected. So it typically is this angle in blue. So that is our angle of deviation. Am I communicating? So the key idea is, how do we find this angle? That should be our main focus. So now we know that from laws of reflection, when a light ray is incident on a plane mirror, then it will form an angle of incident I, where this angle will be the angle between the incident ray and the normal. The normal we have here is NO. Perfect. Typically a perpendicular distance to the mirror. Now, when the ray of light is being reflected, it will also form another angle which we call the angle of reflection. However, experiment shows that this angle of reflection, and according to the laws of reflection, would always be the same as the angle of incidence. So we represent that with R, but R is equal to I. Perfect. Now, there's something called glassing angle. This angle is the angle between the incident ray and the mirror when the incident ray strikes the mirror. And that is the one we have right here in green. So we represent that with G. Are we here? We represent that with what? With G. So glassing angle is the angle between the incident ray and the mirror. Now, since we said that whatever the incident angle is, the angle of incident is, that's exactly what is going to be the angle of reflection. So this clearly means that the glassing angle on the right hand side will also be the same. Are we there? Because this total angle is 90. And by the time we do 90 minus half, we will get the glassing angle, which will be this portion. However, if you do the same thing for the left hand side, we will still have the same glassing angle. So it clearly means that the glassing angle is always the same in all cases, either for the left hand side relative to the angle of incidence, or for the right hand side relative to the angle of reflection. You will see have the same thing. But we learned geometry. From our knowledge in geometry, we know that vertically opposite angles are the same. These are angle forms when we have two lines to cross themselves when they are both straight lines. Now, look at the incident ray we discussed earlier. Look at the way it comes if it's not being reflected. Perfect. Straight line, isn't it? Good. Now, look at the direction of the mirror as well. a horizontal straight line. Excellent. So what we want to figure out, we can clearly see that there is an angle which we call the glassing angle between the incident ray and the mirror. Now, from acknowledging vertically opposite angle, this clearly means that this angle also, since they are being formed in the opposite side and is formed by the same lines, then it means this place will also be vertically opposite angle. Are we together? It's also vertically opposite angle. Thus, we have been able to get our angle of deviation D. So let me have that in blue. So clearly, our angle of deviation D would be equal to the sum of two glassing angles, which is simply 2G. And this is what you need in next sense. So how do you arrive at this? If you are given the incident angle or the angle of incidence, and you are required to find the angle of deviation, basically you need the glassing angle first. However, to get the glassing angle, just know that the angle of incidence and the glassing angle are complementary, meaning that they sum up to 90. Actually, with this illustration, you should be able to realize that. So with that, you can get the glassing angle. And having gotten the glassing angle, you multiply that by 2 to get your angle of deviation. And it's simple as that. So that's the basic idea behind the angle of deviation of a light ray on a plane mirror. So I hope you find this understandable. To put this into good use, let's consider some examples. Example number 1. A ray of light strikes the surface of a plane mirror at an angle of 35 degrees. What is the angle between the reflected ray and the incident ray after reflection by the mirror? So let's begin by a visual illustration. So if we have the mirror, we have a ray of light to strike the mirror. Perfect. Now, when we are dealing with rays, we need to show the direction of the path at which the ray is moving. So this is our incident ray. From the problem, it clearly says that it subtends an angle of incidence of 35 degrees. So we actually need the normal. So if this is our normal to the mirror, then the angle between the incident ray and the normal is 35. Perfect. Now, if at all the incident ray is not being reflected, then we should have gone this part. Is that straight enough? Let me do it again. Okay, just work with that. However, it actually gets reflected and moved in this part, thus forming the reflected ray. Likewise, the angle of reflection. Now we said from loss of reflection, the angle of incidence will be the same as the angle of reflection, 35 degrees. And this is our reflected ray. Now basically, the problem requires us to find the angle between the reflected ray and the incident ray after reflection. So that's clearly this angle. Remember, we said the angle of deviation is the angle between the reflected ray, which is the part that the incident ray take when it's being reflected, and the part that the incident ray is supposed to take if not being reflected. So that's simply the angle of deviation. So we represent that with D. So how do we get D? Remember, earlier we said that D is equal to 2G, where G is simply the angle of the glassing. So typically, to get G, we need to subtract 35 from 90, because G plus I is equal to 90. If you want to consider G plus R is equal to 90, regardless, you are still doing the same thing. Perfect. So since I is 35, it means G plus 35 would be equal to 90. And clearly, the glassing angle would be 90 minus 35, which would be equal to 55 degrees. So this is our glassing angle. Typically, in terms of illustration, it's this region. This is where we call the glassing angle, for those who might still be wondering. Now that we have the glassing angle, we can proceed on getting our angle of deviation. Thus, that will be equal to 2 times 55. And upon doing this product, we will have 110 degree. And that's simply our angle of deviation. So guys, this is how you can easily and mentally find the angle of deviation given either the reflected angle or the incident angle. Are we together? Perfect. On to example number 2. Feel free to pause the video and figure this out yourself. By the way, if you are yet to subscribe to the channel, feel free to subscribe. A ray of light meets the surface of a plane mirror at an angle of incidence of 50 degrees. What is the angle of deviation of the ray after reflection? Well, I changed my mind. You'll be using this as an exercise, so feel free to share a solution with me via the comment section below. So what do you get as your angle of deviation? Let me know. Thanks for watching once again. I hope you find this helpful and understandable. Bye for now.